search engine. Now, technically, it's not a search algorithm, but a ranking algorithm. So when you type a query into a search engine, then there are literally millions of pages which will match that query. What PageRank does is to rank all of those pages such that the one at the top is the one that you're most likely to be interested in.
Larry and Sergey came up with the idea to do PageRank, to use it as a ranking signal to improve the quality of web search. I remember myself at the time, you used the web search engine like Alta Vista. You would have to click the next page link a lot of times to find what you were looking for. PageRank was one of the reasons why Google was so much better than the existing search engines at the time.
The inner workings of PageRank are hidden from view on the World Wide Web. So to reveal how it does its job, we're going to use the PageRank algorithm to rank the players of a football team.
PageRank looks at two things. It looks at the incoming links to a web page, that is, the other pages that link to the page, and it looks at how important those pages are.
In our demonstration to show the cleverness of the PageRank algorithm, the players in the football team are the web pages, and the passes between them are the web links, the input for the algorithm. Generally speaking, the PageRank algorithm will give a higher rank to a website if it's got a lot of links coming from other websites. So in the case of football, if a player gets more passes from the rest of the team, then they'll be ranked higher. It's not quite that simple, because the PageRank algorithm actually gives more weight to a link from a website that itself has a high page rank. So actually a pass from a popular player is worth more than a pass from a player who's hardly involved in the game at all. This is a visualization of the algorithm at work. The stats are the player's current ranking, the output of the algorithm. But every time there's a pass, these rankings are updated. When Google uses this algorithm, it only changes one thing, the input. In place of passes, it uses web links.
Note that the importance of a page depends on the importance of the pages that link to it. This means that you have to compute PageRank for all the pages at the same time. And you actually have to repeat the computation because each time you update the importance of all the pages. And that in turn will influence the importance of the pages that those pages link to.
At the end of the match, the job of the algorithm is done. If we wanted to search for the key player in the team, this is PageRank's answer. Player 11 has the highest PageRank score.
I think the PageRank algorithm is probably my favourite algorithm of all time. And it's amazing that it can be applied not just to the World Wide Web, but analysing a football match as well. But for me, it's the fact that there's a beautiful bit of mathematics at its heart that always seems to find the website I'm looking for.
Within Google, I think PageRank is seen as a very important part of Google's early development.
PageRank was the secret to why the search engine that Larry and Sergey built in the 1990s was so successful. Now, Google handles over 3.5 billion searches every day. It's the world's most popular search engine. And the company is worth more than $450 billion. Not bad for two PhD students working out of a garage. Algorithms are simple step-by-step recipes. Inventing them requires incredible creativity and genius. But using them is just a matter of following instructions. And this is why algorithms are perfect for computers.
Computers are just machines. They just do repetitive tasks at phenomenal speeds, unbelievable speeds. So they're absolutely perfect for performing these repetitive tasks that are unambiguously defined and can be done in a finite amount of time.
Computer code is basically making an algorithm specific. So the algorithm is the kind of idea, how would you solve the problem, these are the rough instructions that you would use, and then that can be translated into particular code.
Lots of types of algorithms have been created with the computer in mind. And some of the most important are sorting algorithms.
Now, the job of the sorting algorithm is to put things in order, and they have lots of uses. For example, on the internet, information gets broken down into packets of data, which then get sent across the web. Now, to reassemble that data, sorting algorithms are absolutely crucial to putting this data back in the correct order so that we can view the picture or read the email we've just been sent.
This is the System Development Corporation in California. It's considered to be the world's first computer software company. And it was here in 1963 that two computer scientists first formally wrote down one of the most iconic sorting algorithms of all time. It's called bubble sort. And here's an example of bubble sort in action, sorting blocks instead of numbers. It gets its name because with each round of the algorithm, the largest unsorted object bubbles to the top. Like all our algorithms so far, there's method in the madness. To see how this algorithm works, we're going to use it to sort 8 objects. Now the bubble sort algorithm says to consider the objects in pairs and swap them over if they're in the wrong order. So we're going to start at this end here and work our way to the top. So I consider these two, they're in the wrong order, so I swap them over. Consider the next pair, they're in the right order, so I leave them as they are. Consider this pair, they're in the wrong order, so I swap them. And we just continue doing this.
Now the bubble sort algorithm says to go back to the beginning and repeat the process over and over again until the objects are in order. The algorithm stops when there are no pairs to swap around. So the bubble sort algorithm has successfully done its job. I've now got the objects perfectly ordered according to ascending height.